Today we are going to start with the two-port networks. Okay, where see here two-port network parameters. Screen is visible, right?
Yes.
Yeah, two-port network parameters. Here in this topic, we're going to see a definition of two-port networks. That is, first one is Z, next Y, then H, then ABCD. Z parameters, or simply you can call it as impedance parameters or open circuit impedance parameters. Open circuit impedance parameters. Okay, then Y. Y is
Admittance.
yes admittance parameters. Admittance parameters. H is hybrid, both hybrid parameters. Then transmission line parameter, that is ABCD parameters. Okay, before discussing this, now what do you mean by port? Port is nothing but a pair of terminals where we are going to connect our energy source and the load. Always we require pair of terminals. Okay, we are going to call it as a port. Here we are going to study two port network parameters, in that Z, Y, H and transmission line parameters. Okay, now what are the different type of port? First one is one port, second one two port, then third one is multi-port. Here I can see one port in the sense there are only one setup, means only one set of terminals, that is one pair. This is network 1 dash. I can call this one as a one port network. Two port, this is my network, input port as well as output port. 1 dash, 2 dash. Okay, then multi-port, that is network one dash, 2 dash, 3 dash, n dash. Okay, these are some networks with pair of terminals. Here input and output ports are there for a two-port networks. Here in this topic we are going to study about the two-port network parameters. This one we are going to study. Okay, now how we are going to start with the actual analysis for the two-port networks. Before actual analysis, we need to assume some assumptions. First one, voltage and currents in the actual network are not available for the measurement. Okay, here whenever I am seeing a two-port network analysis, 1 dash, 2 dash. Here I can connect my source. Here I can connect my, as well as I use this measurement. See, network. Okay, here 1 dash, 2 dash. This one I am going to call it as input port. and this one as output port. Or simply I can call this input port as a driving point, DRI, driving point. Okay, here I am going to connect my energy source to the 1 dash terminal. This is my driving point. 1 dash terminals, pair of terminals are my driving point or input port. 2 dash are my output port. Okay, now these terminals, these 1 dash, 2 dash terminals are useful for making the measurements. Draw see here, before starting with the ZY ABCD hybrid, we need to understand how my two-port network equivalent circuit or a two-port network with standard voltage and current can be drawn. Okay, this is my two-port network. Okay, this is a two-port network in the sense how many terminals at the input side and how many terminals at the output side, please. Here input side how many?
Two input, two output.
Two input, two output.
Two output.
Yeah, this one is 1, this one is 1 dash, this one is 2, this one is 2 dash. Okay, now I am going to mark some standard voltage and currents. I am going to take with the positive polarity, I am going to mark this one as a V1 volt, this one as a at output side V2 voltage. Due to this V1, the current will flow like this. This is, I'm going to call it as I1. Due to this V2, I2 will flow. I'm going to call it as I2. We can observe here I1 and I2 are flowing into the two-port network. Okay, where we can assume that this two-port network consists only the linear elements. Okay, network source inside this box, I am going to assume before analysis of a two-port network, only linear elements will be there inside this box, or may consist a dependent source. How I am going to draw a dependent source? With polarity or current marked inside. Okay, this two-port network inside this box, this may consider dependent source, but not the independent sources. Okay, and if this network consists of elements, energy storage elements, name any energy storing elements.
Capacitor.
Yeah, inductor and capacitors. If this box, this two-port network, inside this, they consist of energy storing elements such as inductor or capacitor, then initial condition on them is assumed to be 0. Okay, this is the concept behind this one. We already seen how, see, now how we can write linear equations. Linear equations. How many equations I can write from these 4 variables here? How many variables are there? 4 variables. What are those? Yes. V1, V2, I1, I2. Okay. Total 4 variables are there. From these four variables, I can write two linear equations. Okay, how I am going to write? I can obtain these equation. That means I can obtain these linear equations by considering any two variables as dependent. Any two variables as dependent and other two variables are independent. Okay, now there are 6 possible way of selecting independent variables out of these 4: v1, v2, i1, i2. Okay, now we'll start with h parameter, that is impedance parameters, or simply I can call it as a open circuit impedance parameters. Now sorry, z parameter, not z parameters, that is impedance parameters. Okay, for that I need this circuit. Port network. Two dash or minus plus or minus I1 is flowing inside as well as I2 is flowing inside. Now these Z parameters are called as impedance parameters. Okay, these are obtained by expressing the voltages V1 and V2 in terms of currents. How I am going to obtain these impedance parameters? I am going to express these voltages V1 and V2 in terms of I1 and I2. Okay, here I can call I1 and I2 are independent variables. If I am expressing V1 in terms of I1, V2 in terms of I2, then I am going to call this I1 and I2 are my independent variables. Okay, V1 and V2 are dependent variables. Or if I am expressing I1 in terms of V1, I2 in terms of V2, then I am going to call I1 as a dependent variable, I2 as a dependent variable, and V1 and V2 are the independent variable. Here for impedance parameters or open circuit impedance parameters, I am going to express my input voltage V1 as well as my output port V2 voltage in terms of input current I1 and output current I2 respectively. So the equations becomes the equations. How I am going to express V1 in terms of I1 and electricity. V1 is equals to the function variable F1, I1, I2. Then V2 is equals to F2 in terms of I1, I2. Okay, from this equation I can write Z parameter linear equation as V1 is equals to Z1 plus 2 I2. Then V2, see here this F1 and F2 are the functions of impedance parameters. So I am expressing this Z11 I1 plus Z12 I2. Then V2 equals to Z21 I1 plus Z22, I2. Okay, how I am going to write these in a matrix form? V1, V2. Yeah, then impedance parameters Z11, Z12, Z21, Z22 multiplied by I1 and I2. These linear equations I have written in the form of matrix. Okay, or simply I can write V is equals to Z into I. This matrix or from this linear equation, I need to find out those parameters, Z parameter. What are the Z parameters here? By see this matrix, how many Z parameters are there in this matrix, this equation?
2.
Total 4, Z11, Z12, Z21, Z22. Okay, now how we are going to calculate that one? Let's see. Okay, before that, I am going to express this V1 and V2 in terms of equivalent circuit. Equivalent, I am going to write the equivalent network for V1 and V2, these linear equations. This is, which type source is this? Which type of source is this? Yes. This one, which type of source?
Dependent.
Yeah, this is a dependent source. V1, I1, here V2, I2. Okay, now here, this Z12 is dependent on the current of I2. So I can write here Z12, Z12, I2, Z21, I1. Okay, this is my 1, 1 dash. This is my 2, 2 dash. I am simply writing those equation, these equation in terms of the network. Okay, now this is my equivalent circuit. This is my equivalent network. Okay, now how we are going to calculate Z11 and Z21? Karthik, mute yourself. Okay, this is the equivalent circuit. Now we need to calculate Z11, Z11, Z12, Z21, Z22. First, now we can independent variables to 0. What are the independent variables here in this equation? What are the independent? Yes, I1 and I2 are the independent variables. To get Z11, Z12, Z21, Z22, I am going to assign any one of the independent variable I1 or I2 equals to 0. Okay, now first case, let I2 is equals to 0. If I2 0 in the sense, what will happen? Current will not flow through this circuit, so this is open circuited. Okay, let's put I2 0 in equation 1 and 2. Tell me the expression.
Z11 is equal to V1 by I1.
Yes,
Okay.
that is, yes, yeah, correct. V1 equal to Z11 I1. Here I2 is 0. So Z11 equals to V with ohm or, okay, I only told the impedance is Z1 is ohm. Now next, put I2 0 in second equation.
V2 by I1.
Yeah, V2 equal to Z21 I1. This is 0. Then Z21 equals to V2 by I1 with I2 equal to 0. Z11, Z21. Now, next step, case 2. Case 2. Yes. Anyone? Here see, in the first case I made my independent variable I2 is equals to 0. In case 2, let which one?
I1 equal to 0.
I1
is
equals to 0. Okay, now if I'm going to put this I1 equal to 0 in equation 1, what will happen? V1 equals to Z12 into I2. So Z12 equal to V1 by I2 divided with I1 equals to 0 ohm. Then second equation, V2 is equals to Z22 I2 with I1 equal to 0, that is Z22 equals to V2 by I2 with I1 equals to 0 ohm. Okay, now see here, see this expression, Z11 equals to V1 by I1, where I2 equal to 0. I am going to call this Z11 as open circuit driving point input impedance. This Z11 is open circuit driving point input impedance is with the input port, that is driving point. Okay, this is the input impedance. Z11 is open circuit driving point input impedance. Then coming to Z21, open circuit forward transfer impedance. Open circuit forward transfer impedance, because 2 1 it's related to output port 2 also. It is driving. This is forward transfer impedance. Now coming to Z12, open circuit reverse transfer function impedance. Now Z22 is open circuit driving point output impedance. How we are going to see in examination if they ask this one? Okay, you need to mention all these. Z11 is open circuit driving point input impedance. See, everywhere I have written open circuit. Okay, where this corresponding to the condition that one of the port is open circuited. Here we are assuming in first case I2 is equals to 0. So my output is open circuited. In second case, I am considering I1 equal to 0. So my input is open circuited. So I am going to call this Z parameter as open circuit impedance parameters, where Z11, Z21, Z12, Z22 open circuit driving point input impedance, that is Z11, driving point Z11, Z22 driving point output, it's 22 output side driving point, 21 forward transference, 12 is reverse transfer impedance. Now condition for symmetry. The two-port network is said to be symmetrical if Z11 equals to Z22. If my open circuit driving point input impedance is equals to open circuit driving point output impedance, then I am going to say that my two-port network is symmetrical. Okay, then condition for reciprocity. Condition for reciprocity. Reciprocity in the sense what? 1 to 2 1, where Z12 is equals to Z21. My open circuit forward transfer impedance is equals to my open circuit reverse transfer impedance. Okay, this is how we are going to get Z1, Z22. Understood? If you say yes, we'll go with some simple problems.
Yes, sir.
Okay. Now, this is a network given, two-port network. See, if you know loop analysis, that is KVL, then you are going to solve all the problems related to two-port network parameters. Okay. Once we solve one problem, we will get to know. Oh, plus minus V1 plus minus V2. I1, this is I2, 12 ohm, 3 ohm, 6 ohm. This is the network given. Find the Z parameters of the circuit. This question is given for 10 marks. Okay. Simple one. If you don't know the loop analysis or KVL, you will not going to solve how. Okay. Now, first step. What we need to do? First step. Need to mark all the ports. 1, 1 dash, 2, 2 dash. These points. I'm going to call this one as A, this one as B. This is the first step. Draw the given network, mark all the ports or points 1, 1 dash, 2, 2 dash, A, B. Okay. Now, how many loops are there here? plus 2 minus V1 in the sense it's a closed, here one source is there. Means here one loop, here one loop. How many loops? How much? 2 loops. Okay, if I'm going to call this one as loop 1, loop 2. Now, tell me the expression for loop 1 or which path. See, I don't want to confuse you people. There are 2 loops, so I'm going to apply KVL for loop 1 and loop 2. Okay, first loop 1. If my current is flowing like this, next step, I need to mark the loop current. I1 here. No, see, already I2 is flowing here. I can take in this direction, or as I said, I can take same direction. Answer will be the same. Okay, now for our convenient, now see here, I1 is flowing in this direction, so I'm going to take my loop current as in this direction, means clockwise. Here I2 is flowing in this direction, so I'm going to take my loop current as anti-clockwise. This is I2. I1 is flowing here, so I need to mark plus minus plus minus. Then I2 is flowing here, plus minus plus minus. Okay, now tell me the expression for loop 1. Quick. Yes. This loop 1.
V1 minus
V1 minus
12 I1
12I1
minus 6 I1 plus I2.
Yes. 5 plus why I1 plus, not why not I1 minus?
Same direction.
Both are in same direction.
Yes,
Branch.
both are in same direction, so I'm going to mark 6 I1 plus I2 is equals to 0. Okay. From this equation, I'm going to get V1 is equals to 18 I1 plus 6 I2. This is my equation 1. Now similarly, kindly tell me for loop 2. This one.
V2 minus 3 I2 minus
V2 minus 3 I2 minus
6 of I1 plus I2.
I2 plus I1. We are writing the equation for 2 in the sense first we need to write I2 plus I1. Because that is for our understanding. Correct? Equals to 0.
Yes.
Yeah, then V2 equals to 6 I1 plus 9 I2. I am going to call this equation as 2. Okay. V1, V2 we got. From this equation, see here, V1 equal to 18 I1 plus 6 I2, V2 equal to 6 I1 plus 9 I2. Now, how we are going to calculate my Z parameters? I know my, see, I know that V1 is equals to Z11 I1 plus Z12 I2. V2 is equals to Z21 I1 plus Z22 I2. These are my basic linear equation for my Z parameters. Okay, now what I got V1 equal to I1 plus 6I2, V2 equal to 6 plus 9I2. Now I am going to compare 1 and 2 equation with this my Z parameter linear equation. Compare V1, V2 with this equation, then tell me Z11, Z12, Z21, Z22. Yeah, just simply compare. What is the with I1? What is there in this equation 1? V1 equal to 18 I1 plus 6 I2 with I1.
Z11 is equal to 18
Yes, Z11 equal to 18.
ohm.
Next I2.
Z12 is equal to 6.
Z12 equal to 6. Sorry, Z12 equal to 6. Z21
Z21 is equal to 9. Z22 is equal to 6.
6. Okay, this is 6. Z21 equal to 6. Then Z is 9. Fine. Now we got Z11, Z21, Z12, Z22. Okay, so my Z is Z11, Z12, Z21, Z22 is equals to 18, 6, 6, 9. This is my Z parameters. Okay, now if the network is given, if they ask to find us the Z parameters of this network or this circuit, first step, what I did? First step, I marked all the ports 1, 1 dash, 2, 2 dash, A, B. Okay, next I marked loop currents in the direction of I1 as well as in the direction of I2. Okay, third step, I have written the KVL equation for loop 1 and loop 2. From that I got two linear equations, V1 equal to 18 plus 18 I1 plus 6 I2, then V2 equal to 6 I1 plus 9 I2. Then what I did, I just compared obtained linear equations with my Z port basic linear equations. From that, I got Z11 as 18, Z21 as 6, Z12 as 6, Z22 as 9. Okay, now we'll take up another simple problem. You need to solve this one. Fine. Now, wait. Okay, we'll solve on a 3 loop. This is understood, right? Can I delete this one? Yes, guys.
Yes, sir. Yes, sir.
Now, V1, 2 ohm, 1 ohm, 2 ohm, 2 ohm, I1, I2. Okay. How many loops are there?
Three.
3 loops are there. Okay. Now, first step. Need to, what is the first step? Need to mark all the ports. 1, 1 dash, 2, 2 dash. Next step is here. I need to mark these points. Okay, that is A, B, C, D. 1 1 dash input port, 2 2 dash output port. Here A, B, C are this. Now next. See, first I'll write 1, 2, 3, 3 loops. Okay. Now next step. Yes. After marking all the
Apply KVL for loop 1, 2, and 3, sir.
no, before applying KVL, need to mark the loop current direction, right?
Yes,
Yeah.
sir.
Now I need to mark the current direction for my loop 1 as in the same direction of I1. Okay, this is my I1. Okay, here there is no current direction is given. See, for loop 1, I1 is given. For loop 2, I2 is given. So what I'm going to mark? For I1, I am going to mark my loop current in the same direction of I1. For I2 also, I'm going to mark my loop current as in the same direction of I2. Okay, here for this second loop, there is no current directions are given, means branch not given for this loop. So for my convenient, what I'm going to do, whatever my first direction loop current direction is there, I'm going to mark the same current for this loop also, that is I3. Or I can take I1, I2, I3, or I can take I1, I2, I3. Because I2 is already here, that named. So I'm going to name that branch current I2 and the loop current I2 in the same direction with naming also same I2. Here I3. Okay. Now, I don't want to confuse while writing the equations for loops. So here I'll mark this one as 3, this one as 2. Next step is apply KVL. Apply KVL for loops. Now, loop 1. Anyone tell me please quickly?
Sir, V1 minus I1
V1 minus I1.
minus 2 into I1 plus I2.
I1, I3 same direction. Okay. I1 plus I3. I3. This is I3. Okay. I3 is equals to 0.
0.
Okay. I'll get as V1 equals to 3I1 minus up 2I3.
Yes, sir.
Minus 2I3. Okay. Minus into plus. Correct?
Sir, plus
Yes,
sir.
sir.
Sir,
Sir,
plus
it is
2 I3.
I1 minus I3.
Plus 2 I3.
1
Sir,
minute.
plus are there.
Yeah, 1 minute.
3I1 plus 2 I3.
1 minute equals to 0. V1 minus I1 minus 2I1 minus 2I3 equals to 0. Then,
V1 is equal to 3I1
okay, V1 equal to 3I1 plus
plus
2I3.
2I3.
Yeah. V1 3I1 plus 2I3. I'll call this. Now apply loop 2, not 3, where I2 is there. Yes. This loop. Yes.
Sir, I think there in first loop 2
Hmm.
of
Yeah,
I1 minus
first loop, sir.
I3.
I1 minus
I1
I3, sir.
2 of I1 minus I3.
Yes. I am waiting for your this one. Why? Because these are both are opposite, right?
Yes, sir. Opposite.
I1 is
Yes,
in
sir.
opposite direction of I3. So this is minus. So I got this one as plus. Then minus 3I1 This will be plus. After coming this side, this is minus. Now it's right. 3i1 minus 2i3. Correct? Correct or still confusion is there? No, no.
No, sir.
Yeah. Then tell me the KVL for this loop 2. This
V2 minus 2.
V2 minus
2 into I2 plus I3.
I2 plus, yes, I2 plus I3 equals to 0. V2 minus 2I2 minus 2I3 equals 0. V2 equals to 2I2 plus 2I3. I'll call this equation as 2. Now tell me for loop 3, A, B, C, D.
Minus I3.
Minus minus I3.
Minus 2 into I2 plus I3.
1 minute. You guys need to tell me this one. Minus plus minus. Okay, now tell me minus I3, then minus 2
I2 plus
I3
I3.
minus plus
This is
I3
in
plus
direction.
I2, sir.
I3 plus
Plus
I2. Okay, then
Minus
minus
2 of
2
I3 minus I1.
I3 minus I1 equals to 0. Okay, now simplify this one. I3, 2I3 minus 2I2 minus 2I3 plus 2I1 equals to 0. I3. Minus 3 minus 5I3 minus 2 minus 2I2 plus 2I1 equals to 0. Everyone got this?
Yes, sir.
Now, yeah. Now see here. Here there is no voltage source. Correct? What I told you before, current. What are the currents are there? Here I1 and I2 are in, but V1 and V2 are dependent sources. V1 and V2 are dependent. V1 depend on I1 and I2. V2 depend on I1 and I2. Okay. Where I3, I need to calculate for I3. That is minus 5I3 equals to 2I2 minus 2I1 or 2I1 minus plus 2I2. Okay. Minus minus get cancelled. Say simply I'm step by step answer. I3 equals to 2 by 5 I1 minus 2 by 5 I2. Check this one is correct or not. I3 equals to 2 by 5 I1 minus 2 by 5 I2. Correct? Check.
Yes, sir.
Yeah. Now see here. I need to insert this value of I3 in equation 1 and 2. Then we will get two linear equation in terms of V1 and V2. For that, I'll remove all these things, but I'll just put V1 and V2. This one also I'll remove. Here, this also remove. Okay. Now, put insert I3 in this equation. Insert I3 in equation 1. V1 equals to 3i1 minus of 2. Okay, 2 by 5, how much? Tell me in point. 2 by 5. 0.4. Okay, 0.4 I1 minus 0.4 I2. Correct?
Yes, sir.
Now V1 equal to 3I1 minus 2 into 0.4. 2 into 0.4.
0.8.
0.8 or 4 by, okay, 0.8. 0.8 minus 0.8 I2. Okay, V1 equals to 3 minus 0.8
Plus 0.8 I2.
plus 2.2. 2.2 I1 minus 0.8 I2. This one I will call as equation number 4. Okay,
Plus
now correct na?
sir, plus 0.8 I2. Minus into minus.
Yes, correct. Plus 0.8 I2 plus 0.8 I2. Now insert I3 in equation 2. My equation 2 is this. Okay, I am going to insert here V2 equals to 2I2 minus of plus of 2 0.4 I1 minus 0.4 I2 to 2I2 2 into 0.4 0.8 0.8 I1 plus minus 0.8 I2. Then V2 equals to how much? I1, then 2 minus 0.8 1.2 plus 1.2 I2. This one I'll call it as equation 5. Okay, we know that my linear equations V1 V2 are Z11 I1 Z12 I2 Z21 I1 plus Z22 I2. Okay, compare 6 7. Compare equation 4 and compare equation 4 and 5 with the equation 6 and 7. Okay, what I'm going to get? Z11. Tell me please.
2.2 Z11, sir.
2.2 ohm. Next, Z12. We are just comparing
0.8.
0.8 ohm. Then 2 is 1.2 ohm. So I can simply write Z equal to Z11, Z12, Z21, Z22 equals to 2.2, 0.8, 0.8, 1.2. Okay, here we can see Z21 is equals to, see here in this impedance parameter, which all the values are equal.
Z12 and Z21.
Yeah, Z12 is equals to 21 equals to. This is the condition for what?
Reciprocity.
Yeah, Z12 equals to Z21 is the condition for reciprocity. If Z11 equals to Z22, that is the condition for symmetry. Okay, and we'll solve another problem on this and will wind up, okay, with some dependent source. Then we'll get to know. Okay, which one will take? Okay, fine. This is the network given. One minute. Yeah, big only will take. Yeah, no problem. With dependent sources. This is given as 2V3, 1 ohm, 2 ohm, 2 ohm. This is V1 plus or minus. This is V2 plus or minus. This is plus minus 3I2. This is source depending of the current of I2. Here I1 is given. This is I2 is given. Here plus or minus V3 is given. Okay, circuit is visible. Correct? Yes? Now, mark all the points. 1, 1 dash, 2, 2 dash. Then A, B, C, D. Okay? Next. Yes. First step is marking all the points. Input port is 1 1 dash, output port is 2 2 dash. A, B, C, D are the points. Now, next step.
Loop current.
Yeah, loop currents. See, I1 is flowing in this direction, so I need to mark in this same direction only. I1, I2 is flowing in this direction, so I'm going to mark in this direction only. Then here you see this dependent source, dependent current source, voltage dependent current source this is. Okay, this current source depend upon the voltage V3, the voltage across 2 ohm, and the current direction is given in this direction. So simply, without assuming nothing, I am going to mark this one in the same direction of 2V3. This is I3. Okay, now next step. Next step. See here. What I need to do. current entering into the point, I need to mark it as plus minus already there. Okay, now here current entering plus minus, here current entering plus minus. Okay, now we have 3 loops, 1 2 3. Next step, see from the figure we can see that this V3, okay, I can write the equation for V3. See here, V3 equals to, how I can write, which are the currents are flowing through V3 here, B to D.
I1 and I2.
I1 and I2. Okay, now or simply I will solve as usual. Apply KVL for loop 1. Yeah, apply KVL for loop 1. Tell me.
V1 minus I1.
Yes, plus 2 minus V1. Then
V1.
minus I1. Then why guys getting bored or what? Loop 1. If you want, I can call a particular name and ask for the loop equations. But I don't want to waste my time and energy in that. Please, anyone come forward and tell me the expression for loop 1. Minus V1 minus I1. Here plus 2 minus 3 I2. Then minus 2 I1 minus I2, because I1 is in the opposite direction of I2. Okay, 2 minus 2 I1 minus I2.
I1
Correct?
plus I2. I1 plus I2.
I1 plus or I1 minus?
I2.
I1 plus I2 is equals to 0.
So even V1 is negative, positive.
That's why I'm asking. See, V1 minus I1 minus 3I2 minus 2 I1 plus I2 equal to 0. So I'm going to get my equation V1 is equals to 3I1 plus 5I2. I will call this equation as 1. Okay, now apply KVL for loop 2. Minus to plus, potential gain V2, then minus 2 I2 minus I3, then minus 2 I2 minus plus I2 plus I1 equals to 0. This equation is correct or not? Just check.
Yes.
Yeah. V2 minus 2I2 plus 2I3 minus 2I2 minus 2I1 equals to 0. Minus 2 minus 4, that is V2. I'll get V2 is equals to 2I1 plus 4I2 to I3. I call this equation as 2. Okay.
Yes.
Now apply KVL for loop 3. Apply KVL for loop 3. Yes.
Minus 2 I3 minus I2.
Minus
2
I3
minus I2.
See here, in loop 3, I3 is in the same direction of that 2V3, that dependent source. This is voltage dependent current source. So I can write 2V3 or I3 is equals to 2V3. Check. See here, my loop current I3 and my voltage dependent current source are in the same direction. If this is in the opposite direction, I can write this one as I3 is equal to minus 2V3. Here I3 is equals to 2V3. By seeing only we can tell that. See here, I3 is equals to 2V3. Yes. Now V3 is equals to V3 is equals to 2. See here, V3
I1 plus I2.
I1 plus I2. Why? I1 is also in the clockwise direction, I2 is also clockwise, or simply I1 and I2 are in the same direction. So I can write the equation for V3 as V3 equals to 2 I1 plus I2. Okay, now I know I3 equals to 2 V3. So I will put this one in this equation. Then my equation will become, I just remove this. Then my equation will become I3 is equals to 2 angle of I1 plus I2. That is 2I1 plus 2I2. Okay, I3 equals to 4I1 plus 4I2. This one I will call as equation 3. Understood? Yes? How I am writing this I3? Now I need to put this I3 in equation 1, in equation 2. Because V2 involves 2I1 plus 4I2 minus up 2I3. I need to put this I3. Okay. Put I3 in equation 2. Okay. V2 equal to 2I1 plus 4I2 minus 2 4I1 plus 4I2. After simplifying, V2 equal to 2i1 plus 4i2 minus 8i1 minus 8i2. V2 equals to how much? Minus 6i1. Yes, minus 6i1 and minus 4i2. This one I call it as equation number 4. Now I got two linear equations, that is for V1 and V2 in terms of I1 and I2. Now, now what I need to do for calculating the Z parameters?
Compare.
Yeah. 1 minute. Now I simply compare equation 1 and 4 with V1 equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. Okay, compare equation 1 with these equations. Tell me Z11, or else simply wait, Z equals to Z11, Z12, Z21, Z22. Now fill this. Yes. Three,
5.
3, 5.
Minus 6.
Minus 6,
Minus
minus 4.
6 minus 4.
Yes. These are my open circuit, what do you call? Open circuit impedance parameters or Z parameters. Okay. Now